HTTPS, and let's kind of quickly understand like what all things can be, what all things we need to know about the HTTPS part. So one of the things that I assume that most of you guys already know that HTTPS is used to kind of encrypt your traffic. So let's say you are visiting google.com, for an example. Let's say you are visiting facebook.com over HTTP protocol. Okay. So what will happen is that if you recall, let's say 9 years or 8 years before, by this time, the Facebook was actually running over HTTP protocol. Okay, if you recall. Okay. And the HTTPS mode was actually optional. It was almost, I will say, 10 years back. Okay. But then after some time, the facebook.com started only working on HTTPS. And why the reason that Facebook opted this one, HTTPS mode? The thing is that what was happening is that if you were visiting the facebook.com over HTTP, so all your data, so let's say over here, so let's say this is your computer, this is your computer, this is, let's say, the Facebook server. Okay. And let's say this is your home router. Okay. And let's say this is the internet. Okay. So the connection to Facebook is going from computer 1 to router, then router to the internet, and then internet to the Facebook server. Okay. So what is happening is that let's say I am the attacker for an example. And let's say I am somewhere located at your home, and I am kind of sniffing the traffic that is going back and forth between computer and your router. So what would happen is that using this I can actually see the traffic that is you are transferring from your computer is going to router. And from there, I can read in plain text what kind of thing you are posting on Facebook, what is your cookies, and all the other details in plain text. Okay. So this is actually called as almost like man in the middle attack. Okay. MITM attack. Okay. Roughly MITM attack. And thing is that if you were visiting the facebook.com over HTTP, I could see, okay, what is the kind of traffic that is going back and forth between you. And what I could do is that I can copy the cookies that is going back and forth in plain text. I can record that in my own browser and log into your Facebook without any username and password. In similar way, because this packet is going back and forth in a plain text all over the world, and then it is reaching out to the web server. So anyone, even over here, any of the attacker, even anyone on the internet, if that packet is going by the router, which is, and if the person is on that router, or let's say somehow in that router vicinity, they can also kind of see the data that is going back and forth between you and Facebook in plain text. Okay. So think that how this was solved. This was solved by utilizing HTTPS. Okay. And what this HTTPS does is that the traffic that is going, let's say, back and forth between the your computer and the Facebook server. So it is all encrypted. With a key that only you and the Facebook guy know, the Facebook server know, and no one knows about that key. Okay. So now if an attacker is tapping on this traffic, they can capture the traffic. But they won't be able to decrypt that traffic and know what kind of data you are transferring between computer 1 and Facebook. Okay. So that's the usefulness of the HTTPS. So HTTPS actually allows you to encrypt your traffic so that no one else, even if they are kind of capturing the traffic, they will not be able to kind of see your traffic. Okay. So whenever we visit a website, let's say if it is HTTPS or not, what we can do is that you see a padlock over here, the padlock symbol. So that actually means that it is encrypted. So if I click on this, it will tell me that the connection is secure, and the thing is that it will tell me that is like a lot of other details, but basically it tells me that the connection is secure. All the data that is going between my computer and this cybercef.com website, everything is kind of encrypted. So even though like attacker is kind of sniffing my traffic, I don't need to worry about that, because they will not be able to, the data will not be able to make sense to them, because it's all encrypted. It is all in encrypted format. Okay, so this is the padlock. And if you see that, okay, you're waiting a website and the padlock is like cross, that means either the website certificate has kind of expired, and that's where the security, the proper security is not in place, and maybe someone can still kind of, let's say, view your data what you are transferring between the computer and the web server. Okay, so this is all about the HTTPS, and let's kind of understand more how the things happen. Okay, so in the meantime, let me quickly see. Okay, I think this is some, I need to know the correct password, and somehow I'm not expecting this authentication required thing, but I'll figure it out. But I think you guys now know what the HTTP response and request header looks like. So that makes sense. And I think, let's see if the browser has opened up. Okay, so it's fine. I think we already have already covered HTTP response, and we have looked one of the example at least where the HTTP response code was 200, and we also looked at the Wireshark module where we kind of figure out, okay, how the response code is looking like for that malicious web URL. So I think we can continue with the analysis of the SSL part. Okay. Now thing is that how can, in a company, let's say over here that there is a user, okay, C1, and they are visiting a web server, let's say over here, web server over here, and how we can decrypt the traffic and see what data is being transferred from computer one to the web server. How we can do that? Okay. So one of the way what we can do in our company network is that we will be setting up a decryption device over here. Okay. I will let you know, I will share more how this decryption will happen, But what this device will do is that, this device will actually allow you, so let's say it is a decryption device. So this device will actually allow you to read the content of the data that is being transferred from computer one to web server in a plain text. Okay, in a plain text, you can review the data. Okay, and how it does that? So what happened is that when, let's say, this decryption device was not in place, so what happened is that, let's say this computer one needs to send certain data. So what it will do is that it will encrypt that data. Okay, and now when that data reached to the web server will decrypt that data. Okay, and it will try to read that data. So the key that is required to encrypt and decrypt is only with the computer one on the web server. Okay, in similar way, let's say there's some data that is about to be sent by the web server, it first encrypt that, and then when that data reach out to the computer one, it decrypts that out. Okay, and how it does that? There is a algorithm in action which is called as asymmetric algorithm. Okay, asymmetric algorithm which is in action, and it has actually a concept of which is say public and private key. Okay, so there's a concept of public and private key over here, and thing is that that's how the encryption and decryption happen. Okay, and now how, as a let's say you are working for a client, and the client have asked you that, okay, they want to see all the HTTPS traffic in a decrypted form. Now let's say how you can utilize that. So how you can do that is that, let's first understand how this encryption decryption happen in a simple scenario. In a simple scenario, what will happen is that this this computer will have its own, let's say, public key, and it will have its own private key. Okay, in similar manner, this web server will have its own public key pu1 and private key prv1. Okay, so what will happen is that this public key of the computer will be initially known by the web server. Okay, will be initially known by the web server. In similar way, this public key of the web server will be initially known by the to the client. Okay, so this will be known to the client.